Given reactants, you can predict the product of a substitution reaction. But there's two ways that this reaction can occur, either headless or two heads. Let's take a look at these two reactions. In the first reaction, the S enantiomer is converted to the R enantiomer. In the second reaction, the S enantiomer produces a racemic mixture of the R and S enantiomers. The mechanism of each reaction helps us explain the stereochemistry. So remember, we can use a reaction mechanism to explain why a product forms. That's reaction 1 from the previous slide. Explain a product distribution, which is reaction 2 from the previous slide. And then we can also choose conditions for a reaction if we want a specific stereochemical product. A reaction mechanism is the sequence by which bonds break and form, going from reactants to products. And we can use curved arrows to show bonds breaking and forming in each step. The stability of the intermediate or product will help us determine the product or products that form. In a substitution reaction mechanism, here's what can happen. Does a carbon nucleophile bond form first? Does the carbon leaving group bond break first? Or does the carbon nucleophile form and the carbon leaving group bond break at the same time? How does the sequence by which bonds break and form affect the stereochemistry? When an alkyl halide undergoes a substitution reaction, remember that the halide is the leaving group. In the SN2 mechanism, the carbon nucleophile bond forms while the carbon leaving group, in this case X, breaks at the same time. In the SN1 mechanism, the carbon leaving group bond breaks first. A carbocation intermediate forms, and then a carbon nucleophile bond forms to form the product. An alcohol undergoes substitution reaction by a SN1 or SN2 mechanism, just like an alkyl halide. So stop the video and use curved arrows to show bonds breaking and forming. Here are the answers. Step 1, make the OH group into a better leaving group, and then the substitution reaction can occur. You might be wondering what SN1 and SN2 mean. The S means substitution, the N means nucleophile. The 1 means is overall first order in one reactant and involves one substance. Note that this step involves the formation of a carbocation. The 2 in SN2 means the rate law is overall second order, which means two substances are involved. So the nucleophile reacts at the alpha carbon and the leaving group leaves at the same time to form the product. So the substitution mechanism for a primary alkyl halide or alcohol is SN2. The mechanism for a tertiary alkyl halide or alcohol is SN1. Either SN1 or SN2 may occur for a secondary alkyl halide or alcohol. So a tertiary alkyl halide or alcohol undergoes a substitution reaction by an SN1 mechanism. Let's review leaving groups. Stop the video and identify the best leaving group. And the answers are, remember that a good leaving group or best leaving group is a weak base. In the SN1 mechanism, the leaving group leaves to form a carbocation. So a tertiary alcohol or alkyl halide forms a tertiary carbocation. Note the stability. So stop the video and answer these questions. And the answers are, in an SN1 mechanism, a carbocation intermediate forms. The stability of that carbocation explains the product distribution. We'll talk more about that product distribution in a second. So this reaction occurs via an SN1 mechanism, so stop the video and explain the observations. So here's the mechanism. Make the leaving group better. Then the leaving group leaves to form a secondary carbocation. Check to see if that carbocation can rearrange. The secondary carbocation can rearrange to a tertiary carbocation. And then the product forms. The substitution mechanism helps explain the stereochemistry of the products. If the mechanism is SN1, a racemic mixture forms. If the mechanism is SN2, we get an inversion of configuration, that is, an R reactant forms the S product. So stop the video and answer these questions. And the answers are, so now we can explain these observations. Stop the video and identify the substitution mechanism for each reaction. So the answers are, so the substitution mechanism type is important if stereochemistry is involved. Let's say you have a secondary alcohol and you want to produce this product. Would you want to use an SN1 mechanism or SN2 mechanism? So stop the video and figure that out. The answer is, we will discuss solvent in a future video. Here are a few things you want to remember to avoid these common mistakes. Remember to make OH into a better leaving group by using an acid. And remember that an SN2 mechanism involves inversion configuration, whereas SN1 gives a racemic mixture of products. SN1 reactions are not popular because a racemic mixture forms instead of one enantiomer. But a chemist figured out a catalyst to use which will convert a tertiary compound into one enantiomer rather than a racemic mixture.